All right, today's lesson is solving two-step equations. The only objective is one, it's just to solve two-step equations. This is a fairly short lesson with some classwork that you'll be doing mixed in. To solve two-step equations, you must undo two operations. So when we're solving a one-step equation, we might have multiplication, and to get rid of the multiplication, we do division. But in a two-step equation, like the ones down here, you have more than one thing happening. You have 2 times x plus 1, so you have to get rid of both operations. Order of operations always tells us that we multiply and divide before we add or subtract. So if we look at this example down here, the 2x plus 1 equals 13, if we were evaluating that expression and I told you what, well, let's say we don't have the 13 here. If we were evaluating 2x plus 1 and I said, let's say that x is 5, you would do 2 times 5 first, and then you would add 1. You would do the multiplication and then the division. All of these are the same. You always multiply and divide first, and then you do the addition or subtraction. But our goal when we are solving equations is getting the variable by itself. By undoing the operations, we have to do order of operations in reverse. So we're going to use reverse order of operations. We're going to undo the addition and subtraction before we undo multiplication and division. And just like when we did one-step equations, when we solved two-step equations, I want you to show all of the steps. So for our first example, we have 2x plus 1 equals 13. We have 2 things to get rid of. We have the 2 in front of the x. We also have the 1 to get rid of. We're going to undo the addition or subtraction first. That means we're going to get rid of the plus 1 first. So I'm going to show my work by showing that I'm going to subtract 1 from both sides. And I end up with 2x equals 12. Now I have narrowed it down. I have a one-step equation, 2x equals 12. I would divide both sides by 2, and I would get x equals 6. Okay, next example. Do I have a volunteer to tell me what to do first? Grace?
You would get rid of the minus 4.
Okay, and how would I do that?
Add 4.
Good. Okay, what do I end up with?
3x equals 17.
No, we have to do 17 plus 4. You have to add 4 to both sides. 21, there you go. Okay, then what do I do?
You divide both sides by 3.
Good. To get x equals 7. And all of these, when we get our answer, we can check it by substituting it back into the original equation. So if we're saying that x equals 7, it better be true that when we put 7 in for this x, we get the right answer. So let's actually check this one. 3 times 7 minus 4 should equal 17. 3 times 7 is 21, and 21 minus 4 does equal 17. So it's always a good idea to go back and check, especially as the equations get longer and more complicated. Okay, next one. Any volunteers to try this one? Adria?
So you have to get rid of the plus 2,
Uh-huh.
so minus 2, and both sides.
Okay, good.
You get 6.
Wait, what do I get on this side first? Go from left to right. What would I write down here?
X over 4 equals 6.
Okay, x over 4 equals 6. Now what?
you have to multiply 6 times 4, or you have to multiply the reciprocal, should be times 4.
Times 4.
So 6 times 4 is 24.
Okay, so x equals 24. Okay, and we should also check this one. So let's put 24 in for x in our original equation. 24 divided by 4 plus 2. 24 divided by 2 is 6 plus 2. And 6 plus 2 is 8. 8 equals 8, so that one checks out. Okay, next 3 are examples for you to try. Make sure that you're showing all of your work, just like we did on these examples. I'm going to leave this slide up so you can see the examples if you didn't take good notes. And then we'll talk about the 3 examples and go from there. Okay, let's go over these examples. Reed, can you tell me what to do for number 1?
You add 10 on those.
Okay. And what do we end up with?
X over 5 equals -2.
Good. Now what do we do?
We multiply x over 5 by 5 over 1 and we get x. And then we get constant here on the other side.
Okay.
And then we get
Very good. Any questions about that one? Okay, number 2, Eli.
First you subtract the 9 from both sides.
Good.
And then you get 4x equals -10.
Good.
And then you have to divide the 4x by 4 and the -10 by 4.
Okay.
Get x equals -12.
Good.
Can't you just keep it in the
If you kept it improper, you would say x equals -5/2. You would still want to reduce it, but you could leave it like that. So either is fine. Okay, any questions about that one? Okay, number 3, Ailey.
We would subtract 6 from -6 and -2.
Okay. And you get
And then we would put, then we would multiply that to, like, then we would take the -8
okay, so we need to write down, what do we write down on this side?
x over
X over 2 equals -8. Okay, now what?
Then we would multiply it by 2.
Good. Multiply by 2, and you can make it 2 over 1 if you want when you do that. And so we end up with
16. This, we would
X.
have 1 here,
Uh-huh.
1 here, and then -16.
-16. Good. Okay, any questions about number 3? How many of you got all of them right? Okay, excellent. Okay, what we're going to be doing now is a partner worksheet. The reason I have you do a partner worksheet is because then you have to show your steps in the right order because you're not going to be doing all of the problem yourself. So first thing you do, you're going to write both names at the top of the paper, and I want you to show your work and put your initials beside the step that you did, or you could use colored pencils or markers if you have them. I have some in the back. I don't really advise markers. Pencils would definitely be better so you can erase. But you can write, like, say, Reed and Jimmy were working together. Reed could write his name in blue, and Jimmy could write his name in green, and Reed would do all his work in blue, and Jimmy would do all his in green. So I can see whose work is whose. You'll get the same grade on the paper, so you want to make sure that you're not just saying, okay, my partner did their step, we're good. You have to check what they did. You want to make sure that they did it right. So you'd write your names. Here's Sam, super student. Let's put him in red. And Mary, math guru. We'll put her in purple. Okay, do I have any volunteers to be Sam, super student? And Mary, math guru. Jake, you can be Sam's super student. Irene, you can be Mary Math Guru. Come on up. So who's going to go first?
I guess I will.
Okay, so switch back to the red pen here then. And you are going to do the first step.
All right.
Brain dead.
This is like Monday, only worse.
Yeah.
Yes, because there's already been
Oh,
2 days
man.
of the week that gone by.
Like hard to write this.
Yeah.
Okay, and then you would stop here. Irene, do you agree with what he did? Did he do everything right?
Yeah.
Okay, so now you go on and do
Which
your
part?
step.
Is it this one?
Yeah, it's that one.
So then, yeah. And that would cancel that out with X. Three.
Okay, Jake, do you agree with what she did?
Yes.
Okay, how could they check, all of you guys can sit down now, how could they check to make sure, 100% sure that this is right? What could they do? Carly?
Make X 3 in the problem.
Yeah, put 3 in for X in the problem. So 4 times 3 is 12, and 12 minus 8 is 4. So you can check your answer. Okay. Your assignment then, you also have a worksheet with individual. I will pass that out after you get going with your partner worksheet. I don't want you to start that until you're done with the partner. Any questions? Ross?
We're going to get more math.
Yes, we will.